Hello everyone. We have a question. It says that the equation of the line is y equal mx plus c, where m and c are constants, and the equation of the curve is xy is equals to 16. So basically we have an equation of line and an equation of curve. In the a part it says that given that the line is a tangent to the curve, when the word tangent is used, that means there is just one point of intersection. And definitely when we say one point of intersection means a common point. So given that the line is a tangent to the curve, express m in terms of c. Because we have a common point, because the word tangent is used, we can equate both the equation of the line as well as the equation of the curve. The equation of the line is y is equals to mx plus c. Equation of the curve is xy is equals to 16. So just rearrange it and make it y is equals to 16 upon x. Now both the equation of the line and the curve are in the form of y, so we can simply equate them and we can write 16 upon x is equal to mx plus c. And after rearranging it and cross multiplication, when this x is multiplied by mx and c, it would become 16 is equal to mx square and cx. Finally rearrange it, mx square, because it contains an x square over here, and xc can be written as cx. Moving the 16 on the other side, make it negative 16. And finally we have a proper quadratic equation in the form of mx square plus cx negative 16. Because it is a tangent to the curve, the rule says that if you have a tangent, that means the discriminant would be 0. What is the discriminant? Discriminant is b square minus 4ac. Due to tangent, it is equal to 0. So just place the value of b, a and c. The value of a is m. The value of b is c. The value of c is negative 16. In this discriminant, get it and then simplify it, and c square minus times minus is plus, 4 times 16 is 64m. Because the requirement of the question was express m in terms of c, so just let m be over here, move this c on the other side, and after that divide by 64, because the requirement of the question was express m in terms of c. So finally we have an condition, m is equal to minus c square upon 64. That means m in terms of c. So finally we are done with the solution of a part. In the b part it says that given, instead that m is negative 4, that means instead of m now we could replace it with negative 4. Find the set of values of c. Now the condition is different, because they have used the word set of values. Definitely now it won't be a tangent. Let's read the question and understand what it is asking. Find the set of values of c for which the line intersects the curve at two distinct points. Yes, because this time they have used the word two distinct points, not the word tangent. That is why they have used the word set of values. Because if they would have used the word tangent, definitely we would have an exact answer, not the set of values. So for two distinct points, definitely the discriminant would be greater than 0. This is as per rule. If we have two distinct points, the discriminant is greater than 0. If it is tangent, the discriminant is equal to 0. Because two distinct points, definitely we have point of intersection, but this time we don't have one point of intersection like tangent. We have two point of intersection. So we can use the same equation, mx square plus cx minus 16, which was basically made by comparing the two equations of the line and the curve. And in this equation, mx square plus cx minus 16, replace it with the value of m, which is negative 4, which is given in the question. After replacing the value of m, now we have a quadratic equation, and we can use the discriminant greater than 0, and we can use the value of a as -4, the value of b as c, the value of c as -16, place it in this discriminant, and we can see that we have a condition where c square, and just multiply this -4 with -4 with -16, and we have -256. It is also a quadratic equation, c square minus 256, but definitely in this quadratic equation the term in the form of c is missing, so we don't have to go for again using the quadratic equation to get the values of set of values. We could simply use a formula which is a square minus b square, because this 256 is a perfect square which is 16 square. So as we can see, we have c square minus 16 square, which is exactly according to the formula a square minus b square, and that is equal to a plus b times a minus b, and the inequality says that it is greater than 0. Now if we just take the roots of the equation from here, we can say that the root of the equation is -16, and from here the root of the equation is simply 16, because we have a quadratic equation in the form of c, and c is representing the x. So I have written over here in the graph as c over here, and definitely y is the function of c, and the two values which are basically, I would say, the x-intercept, but over here it is representing the variable c, they are 16 and -16, so 16 over here and -16. Because the given quadratic equation is greater than 0, that means positive. Greater than 0 means positive. So we need the set of values which would give a positive value of y. So if we just look at the graph, if we take any value greater than 16 would result in a positive value of y, or if we take any value of c less than -16 would definitely result in a positive value of y. So finally we can write the set of values as c greater than 16, so that we could have a positive value as per the inequality greater than 0. So c is greater than 16, and any value less than -16, c less than -16 would also result in a positive value of y because the inequality. So finally we have found the set of values for the given b part.